Okay, so the rules that you're looking at for this problem, it's called the product rule and the quotient rule. So for the product rule, that one says that if you have bases of the same, and product means to multiply, so you would have two things multiplied together, but the base has to be the same. So the base would be the u. And then the powers could be different or they could be the same, it doesn't matter. But the product rule says that the base would stay the same, and then you would take the two powers and you would add them together. So this would be u to the ninth. Well, there's another rule similar to this rule. It's called the quotient rule. And so the quotient rule says that if you have bases of the same, and quotient means to divide. So in algebra and pre-algebra, dividing is with a fraction because that's division. So if you have bases of the same, so in this case, let's say u's again, and you have powers, so I'll say a 5 and a 4 again, 5 and a 4. To simplify, your base would stay the same, but instead of adding the powers, because this is the quotient rule, you would subtract them. So you would get u to the first, which is just u. Okay, so that's technically the rule, and those two rules you need to know. But what we are using here for this one, I thought maybe if you were to write it out so you could see what happens, then you would get more adjusted to the rule. So this is kind of what I was explaining. So if you have u to the 6th, v to the 7th, over u v to the 4th, if you wrote that out, that would mean u times u times u times u times u times u, because the power is 6, so that means there's 6 u's, and then in the denominator you would have a u. So for your u's here, you would divide out, this u will divide out with that u, and it makes a 1. So you got 1 times u times u times u times u times u, which would be u to the 5th. So you can see you've got more u's in the numerator than you do in the denominator. And so if one of those divides with 1, you'd have 5 left. So it makes sense you'd have u to the 5th. So in that same fashion, if you take the v's, you can look at it now. So you've got 7 v's in the numerator, 4 v's in the denominator. So these 4 are going to cancel with 4 of those. It's going to be 3 leftovers. And the leftovers have to be in the numerator because there's more in the numerator. So physically it would look like this: v times v times v times v times v times v times v over v times v times v times v. And so then those 4 v's in the denominator would divide, make all these 1s, so you'd have 4 1s, so you'd have 1 times 1 times 1 times 1 times v times v times v, which is v to the 3rd. So that's why the final answer is u to the 5th, v to the 3rd. So when you're working these, that's kind of what I was thinking when I sent you that email about seeing it visually written out. Okay. Now, once these exponents or the powers get a lot bigger, you're not going to want to do that. So what the rule says is that you would have the base of u, and you'd say 6 minus 1, because there is an understood 1 right there, and then times v to the 7 minus 4. And so I would have u to the 5th, because 6 minus 1 is 5, and v to the 3rd, because 7 minus 4 is 3. And so that's another way you can get that final answer.